On July 17, 1981, the Kansas City Hyatt Regency atrium was packed. At 7:05 p.m., the structural steel collapsed. Two walkways, the fourth floor and the second floor, collapsed onto the lobby, killing 114 people. It remains the deadliest non-deliberate structural failure in U.S. history.
This wasn't a mystery, and it wasn't a material defect. In forensic engineering, we call this a latent defect. It's a ticking time bomb hidden in the design itself. This was a failure to verify the physics of a change that was made during construction. To conduct a structural autopsy, we need to examine the layout. There were 3 suspended walkways. The 3rd floor was offset and independently hung. It survived, but the 4th floor and the 2nd floor were stacked directly, vertically, sharing a single suspension line. The original design intent was a continuous load path. A single 46-foot steel rod would run from the ceiling, pass through the 4th floor beam, and terminate under the 2nd floor. In this configuration, the nut under this 4th floor supports only the 4th floor. In our CAD model, you see that the 4th floor is able to rise up independent of the 2nd floor's behavior below it. The load is P, singular. The weight of the 2nd floor travels right past it, carried by the rod itself, up to the ceiling. But the field contractor requested a change. Threading a 40-foot rod is difficult and expensive. They proposed splitting the rod into 2 sections, one from the ceiling to the 4th floor walkway, and a second hanging from the 4th floor down to the 2nd. It might look like a simple constructability change, a minor detail, but in doing so, they fundamentally altered the free body diagram. As you can see in our as-built CAD model, the behavior has changed completely. As the 4th floor rises, the weight of the 2nd floor is now carried with it. In the as-built condition, the 4th floor beam connection now has to support its own weight, plus the entire weight of the 2nd floor hanging below it. The load on this connection is now 2P. It is doubled. To help you visualize the mechanics, we built forensic simulations of both scenarios. First, the original design. Under the intended single load of P, the stress is high, but the beam holds. The flanges remain rigid. The load path is functioning as intended. But now, look at the as-built condition. Our load is 2P, it's doubled. We modeled the exact geometry. 2 C-channels that are welded toe-to-toe using a partial penetration groove weld, which was specified in the fab packages. Watch the bottom flange. Under the increased load, the stress spikes well past yield. The flanges undergo plastic deformation, curling upward. The washer doesn't just strip, it punches straight through the box beam. The physical evidence confirms the math. Look at the atrium ceiling. The hanger rods are still hanging there, completely intact. They didn't snap. The rods held, the nuts held. It was the box beams that failed. They peeled open exactly as our simulation predicted, dropping the walkways down to the floor. The National Bureau of Standards found that this connection, as built, had an ultimate capacity of 18,600 pounds. A code-compliant connection should have held 68,000 pounds. This design failed at roughly 25% of the required capacity. In forensic engineering, details matter. A change in geometry is a change in the physics. Subscribe for more breakdowns. I'm Clay Britton. Stay frosty. C4 is out.